Alright, we're going to be going over some important load chart rules for the telescopic boom crane swing cab, or TLL. This is the new designation that NCCCO has come out with. As you know, they've gotten rid of all the other designations such as the Grove or the National. They got rid of those load charts, and now it's just one generalized load chart based off of the link belt charts that were already a thing through CCO. So we're just going to go over some of the important rules that you need to know for taking this test and remember so that you can pass. And I have highlighted many of them. So we're just going to go through the ones that I feel are important. I'd like you to just skim over everything though, because some questions that you are going to get on this test are going to be in the load chart notes portion of this test. So, setup, the crane shall be level. One, the level shall be on a firm supporting surface. Depending on the nature of the support surface, it may be necessary to have structural supports under the outrigger pontoons or tires to spread the load to a larger bearing surface. And that goes hand in hand with one of the questions they ask: what's the purpose of adding matting underneath your outrigger flow? It's just to disperse the weight over a larger area. So 2, when making a lift on all outriggers, all tires must be free of supporting surfaces. All outrigger beams must be extended to the same length, fully retracted, intermediate, or extended. So that's just saying your tires need to be free of the ground, essentially. You don't want you're not supposed to have your tires technically not supposed to have your tires touching the ground. The reason being is they say, how do you know all the weight is off the tires? Because the tires are conversely part of the counterweight package, or the weight that's holding that crane on the ground. 4, when operating tires, do not exceed 76 degrees maximum boom angle, or loss of backward stability will occur, causing a tipping condition. So remember that question. You might want to know it. This crane capacity shown on fully extended or intermediate extended outriggers do not exceed 85% of the tipping loads. So again, that goes back to 85% on outriggers, 75% on tires or tracks. That is your stability chart for the crane industry. The crane capacity shown on fully retracted outriggers or tires do not exceed 75% of the tipping load as determined by SAE Crane Stability Test Code. I'm going to jump down here to 4. When rating capacities include the weight of the hook, the block, sling, bucket, magnet, auxiliary lifting devices, their weights must be subtracted from the listed rated capacity to obtain the net load which can be lifted. So your rated capacity, or your gross capacity in turn, is everything that your crane can lift. That number that's listed in the load chart, when you go to find your gross capacity, you look in the load chart. Your net capacity is that gross capacity minus your deduction. So you take that rated capacity and you subtract. Say your block is 300 pounds. You subtract 300 pounds from that lifting capacity. You got a jib that's not in use, is stowed. Say it's 400 pounds. You subtract another 400 pounds from that lifting capacity, or that number that is listed in the chart. Rated lifting capacities are based on freely suspended loads. No attempt shall be made to move the load horizontally on the ground in any direction. Remember that. 9. For the main boom capacities, either boom length or radius or both are between values listed. Proceed as follows. Remember this rule. You will need to know this for your test 100%. For boom lengths not listed, use rating for next longer boom length or next shorter boom length, whichever is smaller. All right. So what that means is we're going to come down here, just give you a little run through. Say we have a listed boom length. We have main boom length, of 58 feet. That's our main boom length. We have a radius of 45 feet. Excuse me. So we're in the middle here. We're somewhere between 55 and 60. So what we're going to do is we're going to come down here to our radius of 45. Because you can find it from either side. And we're going to determine, and we'll say we're picking over the front. So over the front. Okay, well, we're going to be at 45 feet regardless of whether we're in the 60 foot chart, boom length chart, or the 55 boom length chart. So we're going to come down here and we're going to determine over the front which one has the lowest capacity. Looks like over the front at 60.3 feet is 19,600 pounds, and over the front at 55 foot is 19,700 pounds. So we're going to go with lowest capacity, which that is the over the front at 60.3 feet. The reason we go with the lowest capacity is you always go more conservative. So with the radius, we always go to the next longest radius. With the boom length, we go to the next shorter or longer boom length, whichever has the lowest capacity. So go ahead and scroll back up. We're going to go back to our load chart problems, and we'll elaborate a little bit more on that as we go. So remember, for boom lengths not listed, use the rating for the next longer boom length or next shorter boom length, whichever is smaller. Whichever is smaller. You want to go with whichever one has the lowest capacity, because if you can get it at that radius with if you can get it at that radius with that lower capacity, you could get it at the shorter at the shorter boom length. If you can get it at that boom length with the lower capacity, 100% you can get it at that radius with the greater capacity. So you don't have to guess when you're between boom lengths. You know already, hey, no matter where that chart is, it's between point A, this rated capacity and this rated capacity. If I'm somewhere in there, then I can pick up that load. So you always want to think conservatively when you're doing these load charts. B. So we're gonna just erase this stuff here. B. I'll move down here to B on the question. For radius not listed, use the rating for the next larger radius. So again, we're going to come down here. We're going to kind of use the same problem. This is kind of an easier chart, so we'll just all right. So say we are. Oops, I'll change my color. At 55 foot. Say we're 55 foot boom length. So 55 foot boom length. And we have a 37 foot radius. 37 7-foot radius. And we were picking main boom over the side. So that's our 360-degree chart. So we're going to look at, we're going to come down here, 55-foot boom length. So we already got that selected. Now we need to figure out what chart we're in. It says 360, so over the side. So that's our 360-degree chart. So we know for a fact now we're working in this chart right here. But we're going to be between boom length or radiuses. So when you're between radius, you always go to the larger radius. So say we're at 37, so we're right in here. And we're between these two. Well, we're going to go down. We're going to go down to the larger radius, and that's going to be 40. A 40-foot radius. So now we're going to come over here. We're going to look at our 300. So we're not using this one because this is over the front. We're going to be using this one. 21,500 pounds. So remember, when you're between boom lengths, you go to the longer or shorter boom length depending on the lower capacity, whichever one has the lower capacity for whatever, whether it be 360 chart or picking over the front chart. When you're between radiuses, you go to the next largest radius. So if you're at 37, you're between 35 and 40, you go to 40. If you're at 42, you're between 40 and 45, you go to 45, and so on. Just erase all this stuff here. Scroll back up to our load chart notes, because there are going to be a few questions that are pertaining to your load chart notes. No, we'll skip down here to 13. The least stable rates working area on outriggers is over the side. So your least stable area is always going to be over the side. You don't have as long of a footprint. Your crane is not as wide over the side as it is front and back. So you don't have as much leverage. 14. Rated lifting capacities are based on correct reeving deduction. Reeving. Deduction must be made for excessive reeving. Any reeving over a minimum required wire rope strength, which is 12,920 pounds, any load that's bigger than 12,920 pounds, you have to add another part of line, which gives you another 12,920 pounds. Is considered excessive. So any reeving over the minimum required is considered excessive and must be, so we're sorry, I'll let you follow along right here on 14. Any reeving over the minimum required is considered excessive and must be accounted for when making lifts. Use working range diagram to estimate the extra feet of rope, then deduct 1 pound for each extra foot of wire rope before attempting to lift the load. All right, so we're going to go over here. And then I'm just going to give you a quick rundown on your range diagram because this is what we have to use to find our tip height. So let's say we've got we'll just go ahead and split the screen. We're going to open up this here, document. So we're going to go ahead, say we've got a 60. Let's jump here. Boom. Draw our little diagram. Just going to do a mock test here. We've got a, let's find a little lighter chart. Main boom mode B, say we've got 95 foot of main boom at a 70-foot radius. That says boom mode B. Say our crane is good for Well, that's a bad analogy. We're going to erase this. We're going to do a radius of 40 feet. 40-foot radius. To do a 40-foot radius, 95 foot of main boom at a 40-foot radius. That's going to give us right here. And we're in a 360 degree chart. Well, our line pull is only good for 12,920 pounds. That's our line pull. That's all we can pick up with one part of line. And our gross capacity in this case is going to be 20,800 pounds. Well, we can't pick up 20,800 pounds with 12,920, right? So we need to part up. We need to add 2 parts of line. We need times 2 to get that, to be able, in order to pick that up. So what is 12,920 times 2? 12,920 times 2 equals 12,920 times 2 equals 25,840 pounds. Now we can pick this up all day long. All right, here's another one. Let's say we have, let's erase this. We have 3 parts of line. We have 3 parts of line. So at 3 parts of line, we're good for 12,920 times 3. We're good for 38,760 pounds. That's more than adequate to pick up 20,800 pounds. So we only need 2 parts of line to pick up 2 parts. Pick up 20,800 pounds. But we have 3 parts. So we're going to use our range diagram. So our tip height, say our tip height is 50 feet. So 50-foot tip height. We have 3 parts of line. Only need 2 parts. So you're going to subtract that single part of line tip to ground from that crane, or add it to your deductions, which it's going to be 1 pound a foot. It's 1 pound a foot tip to ground. Tip to ground. So 50-foot tip height, because we have 1 extra part of line tip to ground, because we don't need that line, that extra part of line, to pick up 20,800 pounds. We only need 2 parts of line to pick 28,800 pounds. So that extra part of line, that third part, we're going to deduct it from our crane's gross capacity. So remember, our gross capacity is that hard number in our chart. We're going to deduct that 50 pounds from 20,800 pounds. So from 20, so we're gonna deduct that. So it's gonna be a 50-pound deduction. Sorry, it's kind of messy here. So 50-pound gross from gross capacity. That's a 50-pound deduction from gross capacity because our tip height is 50 feet from the ground. So that's how those work. If you have any more questions about this, we'll go into detail on some of our load chart problems. We'll have that. And you can kind of see a little bit better as we go through the load chart problem. But your tip, remember, if you have any excess reeving, line that you don't need to pick up whatever your gross capacity is in the load chart, then you have to deduct that from your crane's gross capacity when finding your net capacity. It's also a factor when finding your gross load because you have to figure out how much your gross load is going to be. You know, say you've got 10,000 pound item you're picking up plus your block, your ball. Well, your any excess reeving, you got to still have to do the load chart because any excess reeving, when you look at your load chart, is still a deduction. So you have to figure that in as well to get an appropriate gross load question. You get the answer right. Scroll back up here to the notes, and we will be going over some gross load problems as well. But we're just kind of giving you a quick rundown of what you can and can't do. All right, 4. There's another very important one. For fly capacities or jib capacities with main boom length less than 110 feet and greater than 85 foot, the rated loads are determined by the boom angle using the 110-foot boom and fly chart. For angles not shown, use the next lower angle to determine the allowable capacity. All right, so we're going to break this question down. We're going to start with the fly capacities with main boom length less than 110 feet and greater than 85 foot. The rated load capacities are determined by the boom angle using the 110 foot. Okay, a little bit of information we got there. Whoops. So we're going to just break this down here. So anytime you're less than a fully extended boom, you have to use the boom angle when using the load chart for your jibs. So we'll scroll down here to one of our jib charts. So here again, we're going to split this view. We're going to add in I'm going to clear all this out here. All right. So we say we have a main boom. I'm gonna draw our little diagram here. We're lifting off 34-foot fly. Okay, we got a main boom of 90. So we got main boom B. We got 95 foot of main boom at let's go angle here. At a 65.5 degree angle, main boom angle. So we got a boom that's not at 95 degrees, so it's not fully extended at 210 foot, and it's not fully retracted. It's not below an 85 foot. or at an 85 foot. So it's between 85, the main boom's extended between 85 and 110 foot. We're using the 34-foot fly. So we're not going to use the 85-foot main boom with the 34-foot fly because we're going to go to the next longest main boom when using a jib or the fly offset, they're going to call it, but it's a jib. So we're going to scroll up here. We're going to find our 34-foot fly with 110 foot of main boom. Oh, here it is. Looks like I've already been doing some work. So here it is. This is the one we're going to be using. 34-foot fly, offset fly, 110 foot of main boom. And say our fly setting is, our offset is 15 degrees. I'm going to say 15 degree offset. Let's come over here on the left side. We found our correct chart. 110 foot of main boom, 34-foot offset fly, 15 degrees. Remember, it's always going to be a 360 degree chart. So we're going to scroll down here, just to zoom in a little bit so you can see a little bit better. And since we're between, like I said, since we're not fully extended to 110 foot, but we are greater than 85 foot, we are going to go to the next longest boom length. So that's the 110 foot boom length with this particular chart, the 34-foot fly. And that works the same for the 56 fly as well. If you're extended past 85 foot, but you're not to 110 foot yet, you're just automatically going to use the 110 foot chart with the boom angle. So if they had a radius down here of 70 foot, you wouldn't use that. You'd use your 65.5 degree boom angle. Only time you can use that radius is if there is a solid number that is in the chart. Say it was an 85 foot 85 foot boom length or 110 foot boom length. Then you could use your radiuses. But if it's anything other than a fully extended or at an 85% or 85 foot boom length, you have to use your boom angle. So we're going to use our boom angle. So we're at the 15 degree offset. Again, get rid of that. 15 degree offset, 110 foot of main boom, 34-foot fly. Erected, obviously. So we're going to go down here and we're going to find 65.5. 65.7. So we got 76, 74, 71.5, 69.5, 67.5, and 65. Well, we don't have a 65.5. So we're going to go down to the next lower, which is 65.0. And then that's going to be our gross capacity. So then 6,500 would be our gross capacity because we always go down to the next lower boom angle if we don't have a listed boom angle such as 65.5. Now, if we were over... we still don't have one. So if we were over here at the 30 degree, we do have a 65.5, so then we would use 5,800 pounds. But we don't have a listed boom angle in the 15 degree jib offset, so we have to go to the next lowest boom angle. And we'll go over some problems like that in the load charts. As I said before, we just want to kind of get you familiar with the load charts and what the rules that you're allowed, the things you're allowed to do, and the things you aren't allowed to do. Let's go. Back up to our load charts. And then we already went over, we just established that boom and fly chart for angles not shown use the next lower boom angle to determine the allowable capacity. 17. For fly capacities with main boom length less than 85 foot, the rated loads are determined by the boom angle only. Use the 85 foot boom angle and fly chart for angles not shown. Use the next lower boom angle to determine the allowable capacities. So if you have a boom length less than 85 foot, again, we only have an 85 foot boom length and 110. If you have a less than 85 foot extended, you're going to use the angles. Use the angles only for the 85 foot boom and fly chart. All right, 18. The 35 foot boom length capacities are based on a fully on boom fully retracted. If the boom is not fully retracted, do not exceed capacities shown for the 45 foot boom length. So if we are in, say our boom length is between here, we're going to go, like I said, it depends on our capacity, because this is considered full. 35.5 is your boom mode A fully retracted. That's all you've got. That's your first main section. Say we're picking over the front, we have to determine, say we're at 35.7, so, or 30, let's say 37 foot boom length. .37 foot boom length. So we're between 35 and 45. So, and say we have a 20 foot radius. We're going to determine for our boom length whichever is the lowest capacity, just like we did in the last one, and we're going to go with that one. So 35.5, so we are a 37 foot boom length, and we've got 20 foot radius. So we're going to be working here and here. 37 foot radius, so whichever, say we're over the 360 degrees. So we're going to be working here. Here and here. So we're going to compare here, and we're going to compare here. So we're going to go with the lower capacity of 67,400 pounds. And that's going to be our gross capacity that we're going to go by for this load chart. So we're done with that one. And next load charts we have definitions. So load radius, horizontal distance from a projection of axis of rotation to the supporting surface before loading to the center of a vertical hoist line or tackle with load applied. Loaded boom angle, the angle between the boom base section and horizontal after lifting the load at the rated radius. Working area, an area measured in circular arc around the center line of rotation as shown on the working area diagram. Side load, horizontal side force applied to the lifted load either on the ground or in the air. So a horizontal load applied to a vertical plane is what that is going to be. Now, you're going to get questions that are going to give you load chart layouts that may ask you other questions in the chart, such as it's going to look like a load chart. Face value, it'll look like a load chart, but when you read the question, it's going to tell you different. It may not even apply to that load chart at all, such as asking what sections on a crane scope out when. So remember, come to your notes. Your notes have a lot of information in them. Don't forget to read your notes. Your boom mode A, only inner and mid sections telescope. So we got inner, so your boom mode A, inner, mid section telescopes. That's it. It just got one telescoping section. That's going to be your heavy boom mode. Boom mode B, inner, mid, outer mid, and tip sections telescope simultaneously. You see how they're all telescoping simultaneously? These are where all your sections are used. This is considered your long boom mode. Got your base section, your inner mid, your outer mid, and your tip section. So remember, boom mode B, inner mid, outer mid, and tip sections extend. Boom mode A, only inner and mid section telescope. Now, you may get some questions regarding your winch performance or your wire rope strength. Obviously we know our wire at one part of line is 12,920. If you need to find out what your parts of line without using a calculator, how much your crane's good for per parts of line, just come over here in the load chart that tells you one part of line is good for 12,000. 920. Two parts of line, 25,840. Three parts of line, 38,760. But it's always going to be one part of line is good for 12,920. If you have 6 parts line, you do 12,920 times 6. That's how you determine your load, or you take your load and divide it by 12,920. So another thing I wanted to do is say we have a load of 50,000 pounds. So to determine how many parts of line that we need to pick that up, we'll take 50,000 divided by 12,920 pounds, and that's 3.8. So we need 3.89 parts of line, PL, parts of line, in order to lift 50,000 pounds. That means you can't use fractional parts of line. 3.89 is a fractional part of line. You need need to round up to 4 parts of line. So if we had 6 parts of line, then we would deduct 2 parts of line, tip to ground. That would be our deduction that would be added into our load chart. You would subtract that 2 parts of line, tip to ground, 1 pound a foot, and say it was 50 feet to the tip to ground. So that would be a 100-pound deduction, because we're deducting 2 parts of line, 1 pound a foot, 50 pounds, or 50 feet to the tip to the ground. That's 1 pound a foot. So it's 50 times however many parts of line. If you have 6 parts of line extra, it would be your tip height times however many parts of line. So if it was 50 foot from the tip, so we're just using 50 because it's an easy round number, 50 foot, and we had 6 parts of line extra, we would do 6 times 50 equals 300. And that's how you figure out your parts of line deduction. But remember, you may get some questions regarding your winch questions, like what's your drum rope capacity, maximum capacity? That's 743 pounds. Or what's your the total capacity of line, one part of the line? It's 102 feet. With one part of the line, it's 102 feet. So 6 wire rope layers, if you have your maximum drum rope capacity is 743 feet. Remember those questions. Wire rope strength, we went over that, 12,920 per one line pull. It's always going to be 12,920 pounds. That's never going to change. Now right here is our deductions page. Over here is your description of what deduction you're looking for. You just match that up with whatever is in the load chart, and then you add in the weight of that item. Tire inflation is an important one too. You may have a question regarding tire inflation or operating on tires. So if you're on tires, your operating speed driving on tires is with your boom erect is 2.5 miles per hour. You won't need to really know anything about your outrigger spread. When it asks you working area diagram, where do you find the areas of the crane you can work over? It's your working area diagram. So this shows that you can work a 360-degree chart. You see how they got this circle around it? Those are the areas that you're allowed to work on this crane. 360 degrees. This is your working area diagram. Range diagram. So this is where we're going to come and find our tip height at. So an easy way to find this out is, let's jump over here, screen, jump over here. We've got, say we've got a, use 50, let's say, let's jump here, 75 foot of main boom, and we've got 30-foot radius. So we're going to come over here, we're going to find 75 foot, 30-foot radius. I'm going to bring this arc down, and I'm going to bring this one up. Yeah, that's a bad analogy. Let's say we've got 85. Oops. 85 foot of main boom. Arc it down. Bring this up. So that puts us between tip heights. Follow it all the way over to the left side. Well, you always go up when you're at a lower tip height. So we're going to go up to 90. So that gives us an, oh shit, 85, and I got a tip height 90 foot. That's how you find your radius. So we're going to do another one here. I would use 85 as an example. So say we've got, erase this. We got an 85 foot boom. 85 foot boom length. And we've got .70-foot radius. So we're going to follow that line up to where we meet the 85 foot. It's going to be in the middle. And we're going to follow this over. And since we're in the middle, we're going to go up to 60 foot. That's going to give us a 60-foot tip height. Now, this is only for the range diagram. Most of your problems are going to be right at a tip height. You're not. You're going to intervene. They're going to intervene. They're going to intervene at an actual tip height. Say, it's going to be at the 40-foot line. You know, the 40-foot line. It'll be generally be right on a line. Most all of your questions are going to be right on a line. But that's how you find your tip height. You put run your arc from your main boom down to wherever your radius is down here. So this is going to arc down to wherever your radius is down here. Follow that line over to the right hand or the left hand side and circle whichever tip height is over here, and you're going to write it in your tip height spot. Right. And I think that's pretty much it for our tutorial here. We went over our working range diagram, we went over tip heights, we went over pretty much everything that you're going to see on the load charts. So if you have any other questions, just let me know. You can either text me. You should have my number. If you have this, then you have my contact information. So just reach out and we can figure something out, or we're gonna go over it more in depth in class if you happen to be in class.